Alright, so I'm just going to do the first one with you guys today, and then I want you guys to do the rest of them on your own, and then bring them back tomorrow, and I will check them. So it says, write each inequality for each graph, or write an inequality for each graph, and determine 3 possible solutions. Determine if solutions are contained on the boundary line. So 3 possible solutions. I just found 3 points on the graph that I wanted to include as my 3 possible solutions. Personally, I like to choose ones that are on the line because I think that it helps to write the equation of the line later. So the first one that I chose was right here. I found a point that went through the crosshair, so I liked that one. Then I chose one right there. I like that one too. And then I looked for one more, see if you can find it. And then if you look down there in the corner in the left-hand side, there's one more down there, so I chose that one as well. So if I figure out what these points are, I see that the first one is at negative 1, 2, 3, 4, 5. So negative 5, 0. Oops. Kind of gave it all away, didn't it? Let's try that again. Negative 5, 0. Then the next one, if I count over, it goes negative 2, positive 2. And the last one goes to the right, so it's positive 1 and positive 4 because it goes up. Excuse me. The next question says, are the points on the boundary line solutions? And the answer is yes, they are solutions because it's a solid boundary line. So all the points on the boundary line are solutions. And then last but not least, a test point. We always like that test point of 0, 0, so I'm going to choose that test point of 0, 0 here. So I need to write the inequality, which means I need to know what the equation of this line is. So here's how I'm going to find out what the equation of this line is. I'm going to look at my slope. So I did a rise of 1, 2 over 1, 2, 3. And then I just wanted to check it, so I did it one more time. I rose 1, 2 and over 1, 2, 3. So my slope is 2 over 3. So I wrote m equals 2 over 3. And then I'm going to write my equation in point slope formula because I don't have a y-intercept, so I can't do it in that one. If I had a y-intercept, it would be really easy, but I don't, so I have to use point slope formula. So I just chose one of the random points, and I decided to choose x comma y to be negative 2 and positive 2. I just chose one of those 3 up at the top. It doesn't matter which one. So when I write it in point slope form, I get y minus y1, so y minus 2, equals normally, but remember this is an inequality because we're shading, so I'm just going to put a circle there until we figure out which inequality should go there. So y minus 2 and then something, and then I put the slope, so m, which is 2/3, times x minus x1, so x minus a negative 2. And remember those both turn into positives because we have a double negative. Now to figure out which sign goes there, you kind of have to do a little bit of thinking. If you had plugged in 0, 0 into both of them, you'll find out that we actually get a less than or equal to. If you want to kind of just guess one, and then we know it's equal to because the solution or the line is solid, so we know it has to be solid, which means equal to. But you could kind of just guess the direction it goes and then test it with your test point to make sure you guessed correctly. But if you didn't, just flip the sign the other way. So I guessed that it was less than or equal to, and I plugged in 0 for y. So I'm going to go ahead and plug in 0 for x as well because that's my test point. 0 minus 2 is negative 2, less than or equal to 2/3. 0 plus 2 is positive 2. And then on the right-hand side, 2/3 times 2 is 4/3. So I have negative 2 is less than or equal to 4/3, which is, in fact, correct. That's a correct inequality. So that means that I chose correctly, I guessed correctly, and my equation is correct. So that's how you write the inequality for these lines. So go ahead and try your best to do the other 6, and I'll come back tomorrow and help you guys out with the rest of that.